So of course it's equal to something, right? So the base in this problem was 4, and this one it's 10. So instead of raising it to the fourth, I'm going to do 10 raised to the left and the right side. So we do 10 log 10 of 0.00001 equals 10 to the power of y. So these are going to cancel out, as you know, leaving us with the argument. 001 equals 10 to the power of y. But we know what 0.001 is in scientific notation. See, 1, 2, 3, 4, 5, right? 5 decimal places to the right means that I'm going to have a negative exponent, 10 to the negative 5. If I move to the left, then it would be a positive exponent with scientific notation. So we have 10 to the negative 5 equals 10 to the power of y. I have the same form now. They have the same base, so these powers have to be the same. So my answer is going to be negative 5. Okay? So again, this property matters a lot when you're doing it by hand, right? Part D. What if I tell you log base 8 of 2? So my base is 8, my argument is 2. Who cares? Set it equal to y. So my base is 8, so I'm going to go ahead and raise the left and right side to that base. So I'm going to have 8 log base 8 of 2 equals 8 to the power of y, like this. So I know that 8 log 8 will cancel out, leaving me with this argument 2 equals 8 to the power of y on the right side. But what is 8? Isn't 8 really just the same thing as 2 to the third power, technically? So 2 times 2 times 2 is 8. What's 2? So isn't 2 just the same as 2 to the first power, technically? Anything to the first power is always going to be itself. So if I say a to the first power, it's going to be a. So 2 to the first power is 2. So I have 8, which is 2 to the third power raised to the power of y. You know in mathematics that if you take an exponent and raise it to a power, you're allowed to multiply the powers together. So a to the m is an exponent and is a power. I can multiply the powers. I get a to the m times n. So this would be 2 to the first power equals 2 to the 3y. I can multiply those together. Exponent raised to a power means you multiply the powers together. Doesn't matter. I have the same base, so I can go ahead and set the powers equal to each other again. So I say 1 equals 3y. So if I solve the equation for y, that's it. I have my answer. So I get 1/3 is equal to y as my result. And that's what we said, right? We said it's equal to something, and we said y is 1/3 from all our math. Is that clear? Does it make sense how I did it? Step by step. If not, let me know right now, because you're supposed to be asking me questions.
All good.
A little bit only, not a lot. Why only a little bit?
Oh, I said all good.
Oh, I thought you said it only makes a little bit of sense. Okay, so what about the natural logarithm? So what is the natural logarithm? So ln of x is the natural logarithm. That's just the same thing as log base e of x, right? You know e is about 2.71828. We talked about that. So that property I wrote on top, where if you take a log let me just write it down over here better. It's kind of sloppy, but well, if I have the log of a to the x, I'm in the same boat as I am here, right? These are going to cancel out, so I'm just going to get the power. So ln e to the negative 2 is log base e of e to the negative 2. Ln of x is log base e of x. So those are going to wipe out, so all I get is negative 2. Just like that. So whenever you see an ln and e together, you know they're going to wipe each other out. But this is why it actually works, because of this property. So we get this power, negative 2.